Whether your company uses a TPM-like quality pillar or not, the quality department or function has an important role to play within continuous improvement. Hello, I'm Tom. Welcome to my channel. We'll talk about continuous improvement in an industrial setting, and in today's video we'll be talking about the roles quite specifically of the quality function within continuous improvement. So this is broader than just the quality department, and actually it's also a bit narrower than the quality department in some fields. It is maybe a bit less certifying and auditing than the quality department does, but it is a lot more focus on how do we make sure that operations is doing its best and making good products with as little waste as possible. That is basically what the quality function within continuous improvement is all about. Now, we can do this through a very TPM style quality pillar, and that works very well. So if you are setting up or are developing a quality pillar, a quality maintenance pillar, or a progressive quality pillar, or however you call your quality pillar, then this video is probably very good for you, very educational in thinking about how it's set up. I will not go through one of these specific routes to build it up, but I'll explain the general concepts on what the quality pillar needs to bring to the table. Now, if you don't have a formal quality pillar, but you are in a lean or in a Six Sigma type of organization, you have a performance excellence or a continuous improvement program running that doesn't really use pillars, maybe more in work streams, then these are the things that you will need from your quality and technology departments, because that is a bit the thing. Look at, and I have a different video on the roles within the quality pillar, and that they do not come only from the quality department, but that you also see quite a big role there for what in food companies would be a technology department, in more sort of technical equipment type of companies would probably be an engineering department. But those people that do your product development or your packaging development, they also, because they decide on what the product is and how it should be made, they need to be in this sort of quality function of continuous improvement. Now, let's first go over what that quality function, quality pillar is really working on. What are sort of the KPIs they have to improve? You've got claims, and you've got sort of waste. Defects can be, we'll get into them a bit, but it's waste from stuff you throw away. Now, the thing is that this, of course, everybody wants to combat, but the thinking of quality in performance excellence is don't focus too much on that. We analyze this, but these are outcomes. What you actually sort of measure and analyze to then target, they are slightly different. So these are the defects and the scrap. Now, what is that? So a defect is a product that should have been basically something for sale, and it's just not good. Right? So when that gets into the market, it quite likely will become a claim. Maybe just a complaint, but your customer will not be happy. When you do catch it before it leaves your factory, then it will become waste. Scrap is slightly different. Scrap is sort of something you expect to happen. So these are parts of the product that were not really meant to be the final product. If you, for instance, have sheets of steel and you just need to trim them nicely, the trimmings that go off the sides, these are scrap. They were never meant to become the final product, but you do waste the material for making your product. Many products also have sort of conversions in which part of what you put in is lost. You only need a part of the iron ore, you only need a part of the milk that goes in. You have to cut away the tops and ends of whatever product you are making because those are not good enough. When you know that this is just your technology, we're not talking about defects, we're talking about scrap. These will not become claims, right? You're not sending them out, but they are immediately waste. Now, that's why those two are what you really want to focus on, making a good registration, setting your loss intelligence. And what you will actually be improving is not even this, but it is about the processes that make them. So stable process parameters, optimal stable process parameters, that is the main tool that a quality pillar, quality function has within continuous improvement. Because if you can make a good stable process, you will not have defects. And if these parameters are optimized, you will have as little scrap as possible. And both of these make sure that you basically do not have your defects, you do not have your claims always stuff. So that's why this is your KPI, this is what you analyze, and this is what you work on to improve. Now, when we set up a quality pillar, quality workstream or function within our continuous improvement program, we want them to focus on 4 main areas. And the timing is that you will work on those areas sort of at the same time, but there is an order to it, and we'll get to that as well. But it is good to think of the quality function in these 4 areas. So the quality control system, this is not the quality management system as a total. This is specifically on making sure that defects are detected and stay indoors, right? We're not talking about the actual improvement here yet. We're talking specifically about this step here, preventing claims by keeping all the bad stuff inside. So that means having a good detection, a good control system that can monitor product quality, that can filter out those products that do not meet specifications and make sure they never reach your customers. The second function is the defect analysis or loss intelligence, right? If we're talking about scrap, it is more a loss intelligence. The idea here is that you really know where in your process quality problems are made, but also anything that you do find, right? So anything that you make, whether or not it is sent outside, you want to know where it is made. If this becomes rework, or if this becomes thrown away, or it just takes a bit more time, or it actually is sent out to the customer, that is not per se what we focus on here. We just want to know where the problem was made, how it was made, why it was made, so which of the 4 or 6 M's were responsible for making it. We want to know where in our process are we creating defects. Now, because we have rework and scrap and second-grade products and stuff that becomes a claim, you will need to gather your info from different sources usually. You may also, for your own priority setting, choose to say, when it became a claim, we're gonna, for instance, make it 10 times or 20 times as important as when we find it as a defect inside our organization. These are perfectly okay rules, as long as you have that discussion with your management team and with the people who deal with this, that they understand what you have done. Now, when we have that sort of set out, it's also important to keep the basic conditions of our processes, and that is where the third function, third quadrant, really gets in. Process control. And this is not only statistical process control. In fact, this is more the input control. So process control on, say, the 4 M's, right? So you need to make sure that your machines are in good condition, that your materials are within spec, that you have your methods set correctly, that you know what the settings and parameters are, and that your people, your manpower, is trained on those standards. That is a big part of traditional quality assurance. The only thing is that the quality assurance that you need to get certified in ISO standards or OSHA or IFS and stuff like that, if you just do what those programs demand, you get a sort of a handbook instead of what you really need. This is strongly together with operations, with your production and maintenance departments. Here also those product development teams, those technologists, they really get a strong role as well to make sure that we can set good standards and that we can maintain good standards. This is basically the part of the quality pillar, the quality function, that ensures stability of what you do. So to make sure that you're doing the same processes every day, that you know what your people are doing, that you know how to set the machines and get a predictable, reliable product output. That is a big part of what makes the quality pillar valuable on top of just your regular quality work, making sure that this gets into your whole system. Now, of course, you also need to know those 4 M's. You need to know what are we doing with our machines? What are the settings? When is a plunger no longer strong enough? All kinds of things like that. Or when we already do know that and we have a very stable system, can we push the bar a bit? Can we make ourselves more efficient? Basic conditions are in place. Can we now go to that next level? And for that, we look at the processes, we look at the 4 M's, and we analyze how to optimize, how to redesign and optimize our processes. And generally this is done with systems like, there are a couple of different ones as well, but like Six Sigma type of techniques, especially in the quality function, and with things like a failure mode effects analysis, where you are really looking into, so what are all of the factors that are affecting the output of my process, the stability of my process, my product characteristics, and how can we make the most optimal and stable processes possible so that we get a good product in an effective way every day. That really is one of those technology and engineering type of functions, right? This is traditionally not a part of a quality department, but it is a huge part of the quality function that we need within continuous improvement and performance excellence. This all needs to get together. That is what will drive process improvement. Now, this of course also has quite an impact on other functions within your organization. Think about, of course, the maintenance, but also if we're looking ahead about engineering and projects, think about our training departments, operational departments. Here we already see quite a bit of the operations, the production and the training departments that need to make sure that we do the things the same every day. Here we look forward and make changes usually. But all 4 of them, they all need to be within your quality pillar. Now, if we're talking timings, I would suggest that you immediately start with some defect analysis, some loss intelligence, if only to know how good you are at this, right? Can you do a good defect analysis? Do you have the data available to analyze your scrap levels and to see root causes coming from that? It will give you a good priority, because probably that system is okay-ish already in your organization. It will also show you where you have to put more registrations into place. So do the best one you can for now. That's step 1. Then, that is your first priority. Make sure defects stay in-house. You do not want to piss off your customer. That will cost you a lot of money, sometimes quickly, but definitely in the long run. So first make sure that you know that you can test your product, that you know that you can keep defects inside, that you detect defects, and then build out also where did we make those defects. So that combination becomes your first priority. You do this once, as best as you can. Maybe you need to do improvements here. It's a bit of a decision you make. Then really focus on a good quality control system that will feed back into your loss intelligence. Depending on how well you're already doing that, this can take anywhere from maybe a couple of months, 2 or 3 months, up until almost a year. It depends on how good, especially this quality control system was. You don't really wait for this to go to any other steps, but you do it once. Then we go to process control. Now, the reason to not jump to process control immediately is sort of twofold. It is just more important to keep defects in-house, right? Scrap, waste, is generally not as expensive as an unsatisfied customer, as somebody sending in claims. When your customers are already sending in claims, they are very unhappy with you. Paying the claims does not make them happy. They want to have a good product. So when you have high claim levels, you're going to lose your business. But also, you want to know through more this loss intelligence defect analysis set of skills where to focus. Because this is going to be quite a lot of work. Now, maybe you have a very strong quality management system and a good quality control culture already in your organization. But in most companies where I set up continuous improvement programs, this is pretty weak. So most companies, they will have settings books and they will have standard settings for the machine. They will have some quality controls that are sort of halfway in between those. So definitely companies will know how to check for the specs of their product. But then there's a couple of sort of in-between specs throughout the process where you know that your first production steps did their work correctly. So it's sort of more in the process control area. That's often where it sort of stops. But really looking at, are my incoming materials always up to spec? Do I keep using them in the correct way? How much do I dose? Do I train my people correctly? Are the people using their skills consistently and correctly? That part, that can so much help your processes because it stabilizes everything. And as soon as you have stable standards, even if they are not optimal, you at least know that when you change something, the whole organization changes. And you also know that your night shift is the same as your day shift, and that it's not because of some stupid randomness that somebody has a different way of operating. No, everybody doses the same amount, works in the same way, our machines are good, or we notice it and we make corrections. And when you are on these basic conditions, first off, you will have in almost all in all factories, the extent is just a bit different, have made significant improvements. But also, as long as you have a lot of variation in your standards, it's not very useful to be changing the standards. So that's why put very strong focus here. And only afterwards you go to actually improving the standards. Now, of course, when you have already some basic process controls in place and you know how to control your processes, it's good to also already do a bit of that. But here again, we are talking about priority and sort of the order of starting these. Do it once, as good as you can at the moment. Then make sure your quality control system is pretty good before really focusing on the process control. This you do in pilot areas determined by where you have your losses. And as soon as those pilot areas have pretty good process control, you go to Six Sigma, FMEA type of tools to improve the processes there, extending this work to other areas. Now, anytime that you have an acute quality problem that you want to work on, as determined by your defect analysis, which can simply come from we have one big claim and we really want to do something about it, so it sort of trumps the trending. This is how it works, but your sort of priority cockpit sends an improvement team, a Kaizen event, something like that. The DMAIC team to fix a problem. When you have that, consider it as a pressure cooker for that area, for that line, that product, that whatever the problem was. Because when you do have a Kaizen event, a DMAIC, an improvement team, you do all of this on that narrow problem. And the good thing is that when you build up your quality pillar, your quality work stream, the competences of your quality and technology and product teams around it in that way, you will sort of slowly build up the whole process and use these specific high-powered events to get a good set of experience in the whole set of quality tools that we need to build into our performance excellence. And you have a good reason when there is one of these high-power, high-priority quality events, like that Kaizen event, like that DMAIC, like the improvement team, then you know that your organization will move quickly. But don't forget to also build up the support system, because too many DMAIC teams will focus on what are correct settings, teach it out to operations, but then this doesn't really work. So all the rules were set up, but if you don't really do this, it'll fall by the wayside again. While the team is still active, the quality control system is good, but then half a year later, some operators change different roles, you get some new people, they're not trained, and everything falls. That is such a waste. So that's why use that double-pronged attack. You build up your system once, 1, 2, 3, 4, and you use very acute, big priority problems to sort of pilot all of these. By the way, if you do a DMAIC, you will also sort of see at Kaizen events, and you will sort of see exactly this happening as well. First thing you need to do is define your problem, measure it, analyze it, then make sure you have your basic conditions in place before you actually improve. And then make sure this is all controlled again. So you see there, in short, the whole quality pillar. But please build it out for your entire organization, area by area, in parallel to doing a couple of those high-power teams. That way, you set up a brilliant quality pillar workstream, quality function within your continuous improvement house. Now, I hope that earned me a like for this video, but also, if this raises any questions or a suggestion for a future video to dive deeper into one of these topics, do let me know in the comments. I love having those discussions, and I also love it when you share questions or experience with the rest of our community in the comments. For now, I wish you the best of luck improving the quality of your processes and products. And as always, don't forget to also enjoy the continuous improvement journey.